Hi everyone, this is Tutor Marife MCP. I create math tutorial videos that could serve as your supplemental learning resources. In this video, I'll show you how to graph this given linear inequality in two variables. The graph of a linear inequality in two variables is a shaded half-plane that contains the set of points representing all the solutions to the inequality. When we say solutions to the inequality in two variables, we refer to the set of infinitely many ordered pairs that produce a true statement when the values of x and y are substituted into the inequality. Since the graph of a linear inequality in two variables is a shaded half-plane, the first thing that we need to do is to graph the boundary line that divides the coordinate plane into two halves. Remember that the boundary line is dashed when the given inequality symbol is greater than or less than. The dashed boundary line tells us that the set of points along the line are not solutions to the inequality. The boundary line is solid when the given inequality symbol is greater than or equal to or less than or equal to. Let's refer back to the given inequality. The symbol is greater than or equal to. Therefore, we should have a solid boundary line. A solid boundary line indicates that the set of points on the line are also solutions to the given inequality. So how do we graph the boundary line? To graph the boundary line, let's consider the related equation obtained by changing the inequality sign into an equal sign. From the given inequality 3x plus y is greater than or equal to 4, our related equation is 3x plus y equals 4. We're going to graph this linear equation. How do we graph a linear equation? We have three ways. First way is by finding 2 points. We can find 2 points by picking any two values of x and then solve for the corresponding values of y. Remember that only 2 points are needed to define a line. Once you have your 2 points, plot them and sketch the line. The second way is using the y-intercept and slope. In this way, you're going to rewrite the equation into y equals mx plus b form, or the slope-intercept form. And the third way is using the x and y intercepts. You set y to 0, then solve for the corresponding value of x. You set x to 0 and then solve for the corresponding value of y. Plot the points and then sketch the line. I'll be using the second way to graph the boundary line of this inequality. Recall that our boundary line should be a solid line because our inequality symbol is greater than or equal to. Remember that we only need to derive 2 points to be able to sketch this boundary line. Okay, so let's write our equation. 3x plus y is equal to 4. Rewrite the linear equation in slope-intercept form. That means we're going to get y alone on the left side of the equation. By subtraction property of equality, subtract 3x from both sides of the equation to isolate the y on the left side. Cancel out opposite terms. Y is isolated on the left side of the equation. The right side becomes negative 3x plus 4. This is the slope-intercept form of the linear equation. We have y equals negative 3x plus 4. Now that we have transformed the related equation, which corresponds to the equation of our boundary line, into slope-intercept form, we can now define the value of m and b. Remember that m represents the slope of the line and b represents the y-intercept of the line. M is the numerical coefficient of x. Therefore, m is equal to -3. In fraction form, -3 over 1. Any number has an invisible denominator of 1. This means in every 3 falls, we have 1 run. The negative sign in the slope indicates that we have a falling boundary line. B, which is the constant term of the equation, is equal to 4. This is the y-intercept of the line. This is where the line cuts the y-axis. Okay? So remember that we only need 2 points to sketch the line. First, let's plot the y-intercept. It's equal to +4. 1, 2, 3, 4. The line will pass through this point. So we need 1 more point. We're going to use the value of the slope. In every 3 falls, we have 1 run. So we fall 3 units, 1, 2, 3. Then we run 1 unit, 1. This is our second point. Since 2 points are enough to sketch a line, let's connect the 2 points, and this is our boundary line. Remember that our boundary line is a solid line. As you can see, the boundary line divides the coordinate plane into 2 halves. This is the first half plane. This is the other half plane. The next thing that we need to do is to determine which of the 2 half planes needs to be shaded. Remember that the graph of a linear inequality in 2 variables is a shaded half plane representing all the solutions to the inequality. So how are we going to decide which of the 2 half planes to shade? We're going to pick 1 test point. A test point could be any point not on the boundary line. And usually, the best test point that we could pick is the origin, or 0, 0. The only time that we could not pick the origin as a test point, of course, is when the boundary line passes through it. So we're now going to test whether the coordinates of the test point satisfy the given inequality. What are the coordinates of the origin? We have 0 and 0. If these coordinates satisfy the given inequality, then we are going to shade this half plane containing the origin or the test point. If these coordinates do not satisfy the given inequality, then we're going to shade the other half plane, the half plane that does not contain the test point. Okay, so let's substitute x equals 0 and y equals 0 into the inequality. We have 3x plus y greater than or equal to 4. Replace x and y with 0. 3 times 0 plus 0 is greater than or equal to 4. Any number multiplied by 0 is always equal to 0. 0 plus 0 is still 0. 0 is greater than or equal to 4. Is this a true or false inequality? This is a false statement. That means 0, 0 do not satisfy the given inequality. So we are going to shade the half plane that does not contain the test point. This shaded half plane, including the set of points along the boundary line, represent the solution set of the given inequality. This is the answer. That's it. If you have any questions, use the comment section. Again, this is Tutor Marife MCP. Thank you for watching.